Hello, all. Good morning, good afternoon, good evening. I'm Siddharth. And first of all, thank you for joining this session. So, today I will talk about how we can achieve the reliability excellence with SLO management product. Let me introduce myself. I have a 12 plus years of IT experience. Currently, I'm working with Nakaro Software as a DevOps and platform lead. And I love to talk about the SecOps, cloud engineering, SRE, platform engineering, and I'm happy to connect with you guys via the LinkedIn and the mail that I have already put it here. So let's start the session. So the agenda of the today's session is about the quick understanding of the SREs, their principles and practices. Then we see what are the challenges that we face for the SLOs in the complex environment and what should be our approach to solve it. Then we look for the solution by understanding the SLO management. Then we have one use case where we see about to how we can define the SLOs, and as well as we check how we can basically measure the reliability of the system. Then we look for the SLO management products, whatever available in the markets, and then we see some comparisons in between those products. So let's start with the session. So in SDLC that we know that the developers want to go as fast, like they want to do a development feature as fast as possible. Where in parallelly, like operation teams that they look down to slow down the things. They want to make a system reliable. That's where this kind of a misalignment happens in between these two teams, and it often creates tensions. So that's why the SRE comes into the picture. SRE is basically what introduced by the Google in the early 2000, and it is used for to basically measure the and to solve the operational challenges and issues. SRE, it's a job role, it's a mindset, it's a set of metrics that we use to measure and to manage the overall system reliability. So there are some key principles of SRE. First is service level indicator. Service level indicator are the metrics that used to measure the quality of the service. So there are the couple of different metrics. Mostly that we use is availability, throughput, and the latency. Then we have an service level objective. Service level objectives are the target level of that particular matrix. Basically, that the 99.99% of our system should be available. So this is a target level that we set as. So this is SLO is for the internal benchmarking. So SL is a goal rather than a promise, but it is also help for the customers that we define the specific metrics and we have some kind of surety that our system would be available up to this kind of a target. So that we promise to the customers. Then we have an service level agreement. So it's a contract between the end users and the service provider. So if the promises are the breaks, so the service provider is need to pay it or they have some consequences are related to the different payments and they need to expansions of the different subscriptions. Then we have an error budget. But before moving to the error budget, we need to understand that there is a misconceptions in the overall SRE one. So the misconception is that we always look for the 100% of the system reliability. But not, this is not in core. If we look for the 100% of system reliability, it means that our system is available 100% and every time it should be up. But that can't be a case. Of course, in the practically, your system sometimes it would be down and some kind of a disruption can be happen. And it also affect the overall product life cycle because if we go for the 100% of availability, then of course developers need to focus on the reliability of the systems. They can't focus on the feature development. They can't focus on the innovation side. So that's why like the development teams, operation teams and the product teams, they look to and to have the common target levels that need to be set for the overall the system. So that's why error budget comes into the picture. Error budget is it's just the unavailability of that of the particular system that the teams can be tolerate, basically. So how much time that our system could be unavailable, and which is fine for the overall the life cycle. That's why. So when you have an adequate have adequate error budget, so it means you can focus on the product development part. But your error budget is threatened, it means that you need to focus on the SRE part of the reliability of that system. Then the question is how we can basically practice this principle, implement this principle. So we have a different kind of practices. There's a metrics, monitoring alerts. So of course, if we look for the system reliability, so we have a proper defining of the monitoring systems. We need to be have correct metrics for the services. We need to be set the alerts for the error budget. So if the error budget is threatened, so we can have that alerts and we can focus on the system reliability part. Then the demand forecasting and capacity planning. So we this is one key practice where we have enough resources available for the system reliability part. If something happens, so that resources can focus on the improvement sides, can also focus on the reliability part. This is one of the key practice. Then we have a change management and the emergency response where the each teams like the development teams, operation teams can know about the overall process defined for the change management. Like how if the change if the, even the change is small basically, so they should focus on like how we can basically overall do the changes, and it will improve the overall reliability of the applications. Then the emergency response, that of course in the practically if you have a system sometimes that the system would be down, so you need to be like ready with what kind of a emergency comes. So you need to be focused and you need to be to work on that, how early just you can like back your system up and running. And then of course the culture and toil management is one of also the key practice where it is operational workloads that how you manage. So in SREs of course there are each and everything you can't automate, so there are such kind of manual practices that you need to be followed, and accordingly you need to be manage that overall of your operational workload. But these are the some kind of a basic understanding of an SRE. One. Now let's move to the what are the challenges that we faced of SLO for the complex system. Here the complex system means it could be your microservices base, it could be your distributed system. So let understanding the problem. What is a problem? So sometimes what happens when we like to define an SLOs for the complex environment, we SLOs are not aligned with the business goal. It means that the priorities are misalignment. Like we focus the SLOs on the focus on the different metrics, but our business goals needed a different kind of a metrics. So this is the one thing, and the target level is also changed. So this is the one challenge we face with the system, as well as we mostly don't look or focus on the data driven approach. Because if we define the SLOs, we also need to be ensure that what are the previous checks for the data, and accordingly we can measure it and define the SLOs for the systems. And sometimes we our the SLOs have we just set the unrealistic SLOs, and there the KPIs are the completely different, and so we need to be understand the system first, and accordingly we can set the realistic approach for that systems. Then, of course, the distributed systems and interdependencies. If we have a distributed systems, multiple microservices and APIs, and one microservice is dependent on the other service, and they have some other interdependencies, it is really difficult to find out the pinpoint of where the SLOs is violated. So this is the also one of the challenge we faced in this kind of environments. And we don't look on the priority components. It means that according to the system, we need to be define it what exactly user is doing. So we need to be look for their user journey, and accordingly we need to set the priorities of the system, and then we can define an SLOs as well. And of course, the tool limitations is there. Whatever the tools we have, so we have the limited capabilities with respect to that tool. So that is also one challenge. And at the end, of course, the dynamic and evolving systems, we work in the agile environment. Our system is also upscales, we are also upgrades, and we work on the continuous deployment. So we always have the new features comes in. So accordingly, we need to be again set the SLOs as per the changes. So these are some kind of a challenges. So what should be our approach to solve this kind of issue? So first is we need to be understand the system correctly, like what is particular system, what are the different services in the system, what is the user is doing like in the day-to-day activity. So the critical user journeys also need to be understand of that. Then we can go with the designing part, how we can define design and SLOs of that part, critical services, and then we can set a metrics for that. And then at the end, of course, how we can use it effectively, that is the one approach, that accordingly we can move it and we can try to solve this complex issues for that. But the question is, what would be our actual solution for this issue? The solution is the service level objective management. SLO management, it's a life cycle that we need to be defined within our organization. So it involves basically to define an SLOs by aligning the user journey with the business objectives, whatever the business goals we have. So accordingly, we need to be define the user journey first. Then set a realistic targets for the KPI like the uptime, latencies, and the error rate. So that is the one of the key practice that we need to be do. Then we have a different like SLOs, like the composite SLOs. So composite SLOs is basically a combination of individual SLOs that we define it. So if we look to measure the reliability of a complete system, so we need a holistic view of that particular system. Composite SLO comes into the picture in that case, where we have individual SLOs for the different services and basically aggregation of that services. That SLOs is made to create a composite SLOs. And at the end, the correct measuring and the monitoring of system is needed, where we find the correct alerts for the error budgets and the monitoring of the complete system. So what benefits we can get? Of course, the overall system reliabilities and performance would be improved. We have a less downtime, we have a less incidents, we have a less priority issues on that. If we focus on the data driven that we have already discussed before. So the data driven decision making is one of the key factors to prioritize improvement, because if we look for the previous data to understand the system better on that one. And then, of course, to the proactive monitoring of the systems. So it will also reduce the meantime recovery of the system as well. And the communications and collaborations within a team as well. It will also help to share the understanding for the overall reliability process. Then we have a customer satisfaction, of course, via overall by defining these practices and process. And we focus on the innovation part on that. Now let's see the understand the use case of that. This is a simple like the product life cycle of a user journey, where the user is to go into the shopping app and they just put some product into the cart and do the payment. And after that, overall the backend process comes, whereas the warehouse that received it and dispatched the orders, then invoicing happens and the user get the confirmation via the mail. So overall, this journey, let's break into the two parts. So first is the pre-purchase and second is the post-purchase. So in the pre-purchase, the first we understand that the user part is that the put the products or all the pre-purchase system should be available, and user is just purchase the product. So the availability of the overall the pre-purchase system is needed, and of course the payment of the system. And then the secondary part is the post-purchase. So the availability is the more important than the latency. This is the one thing of the system. And the services are in the pre-purchase order the more important than the post-purchase instead. So in the pre-purchase website availability is the slightly more than the payment availability, of course, because the if the website is not available, so user can't go and purchase the part. and then the payment part availability is needed. So accordingly from this user journey, so this we need to be defined it, which are the critical components, which are the critical services, and which are the services, and accordingly we need to be define the matrix for that services. And then at the end, doing the post purchase, of course, the warehouse and the invoicing slightly more important than the emailing. If you will get the email after sometimes, then of course that would be the fine. But your order should be dispatched, and you will have the invoicing is also be should be created. Then after some time, if you get an email, that is fine. So the thing is like that, how we can measure the reliability of this complete user journey. First is identify the services and the dependent components. So from according to this user journey, so we have a store website, we have a payments, invoices, emailing, and warehousing. So these are services that we have identified it. Then we will set up the individual SLOs for each service with respect to the different metrics like the availabilities and latency. And based on the understanding, we will define the composite SLO part, like the pre-purchase user experience and the post-purchase user experience. And at the end, we will look for the composite SLO. As I said, composite SLOs are the aggregations would be about to. So we have the pre-purchase user journeys and the post-purchase user journeys, and the aggregation would help to make the to understand the overall system reliability. This is the simple use case of the overall reliability process. Then we have the SLO management products who can help you define it, the SLO management lifecycle. It also help you to give you the good features. It also give you the features like the composite SLOs. It also give you the user journey. In this overall products, the Harness and Noble 9 are the, I will say, the leaders in that because they have the such kind of different features like the composite SLO part, like the user journey part, even in the harness, it is a complete 360-degree platform. It also give you the specific feature for the service reliability management, in which we can analyze it. We can easily gather to know how why the our system is getting failed. It also help you to set up the governance with the open policy agents, where the Noble 9 is also help you to keep the 3 years of old data, so you can have that previous data to understand your system, and accordingly you can make a decisions. It has a good composite SL feature part, and it also have to define the user critical journey. Then we have some other tools like the Fire Hydrant, Scottcar, ServiceNow, New Relic, which is just fit it under the monitoring part, incident management part, but it is not a specific SLO management product. These are some products available in the market. And now there are like I have done some the comparisons on the basis of the different capabilities like the real time error budgeting tricks and the map SLOs to business capabilities and RCA, and of course the customized dashboards and reports help you, and of course the automation part, auditing parts, and the overall the customized features with respect to the business. You can see they have some tools have some capabilities, some are good in the specific features, some are like fit under the complete category. So the harness is mostly there, Noble line is there. So accordingly you can choose it whatever the requirement, and you can just use the features of that products. This is for this session. So thank you very much for joining this session. Thank you everyone.